Okay, so let us start today. Today we will start with Fourier transform. Question 1. Find Fourier transform. In short, we write FT. Okay. Of xt is equal to e to the power minus at ut. So this is our question. So the time domain signal is minus at ut. Okay. So x omega, the Fourier transform of xt is x omega. Fine. Is equal to minus infinity to plus infinity e to the power minus at ut into e to the power minus j omega t dt. Fine. So we can write it like minus infinity to plus infinity e to the power minus a plus j omega multiplied with t ut dt. So till now is it clear? X omega is minus infinity to plus infinity e to the power minus at ut into e to the power minus j omega t dt. This is the basic definition of Fourier transform. Okay. From the definition of Fourier transform we are getting this. Now we are rearranging it and write it minus infinity to plus infinity minus a plus j omega t ut dt. Now what is ut? What is the value of ut? Ut means if t is equal to t less than 0, its value is 0, and t greater than 0 or greater than equal 0, its value is 1. So we can write it like this: 0 to infinity e to the power minus a plus j omega t dt. Now this is simple integration here, because ut value for t less than 0 is 0. Okay, so we will integrate it and we will get e to the power minus a plus j omega t divided by minus a plus j omega, where t's value is from 0 to infinity. Okay, so we will get minus 1 upon a plus j omega into, if we put infinity t is equal to, then it will be 0 minus, if we put 0 then it will be 1. So this is 1 plus a plus j omega for a greater than 0. Fine. So this is what we have solved. Now we will solve a very interesting, very small problem. Find Fourier transform of xt is equal to delta t. Okay, so now what is the value of delta t? First question. Delta t is 1 for t is equal to 0 and delta t is 0 for any other value of t, right? So let us find, or let us try to find the Fourier transform. So x omega will be, again from the definition, minus infinity to plus infinity delta t e to the power minus j omega t dt. Now the question is, if we break it in three terms, one is from minus infinity to 0, then at 0 to 0, that means at the value of 0, and then 0 to infinity. Okay, or rather than we can write minus infinity to 0 minus, 0 minus to 0 plus, that means at t is equal to 0, and 0 plus to infinity. Okay, 0 minus indicates that very near value of 0 but less than 0, and 0 plus indicates very near value of 0 but greater than 0. Okay, so two term we will get 0, from minus infinity to 0 minus it will be 0, and from 0 plus to infinity it will be 0. The only value we will get is e to the power minus j omega t at t is equal to 0. That means we will get 1. Fine, because we are getting the value only at a particular point and any other value is 0. Next question is very interesting, but before that you will take 2-3 minutes and try to understand what we have done till now. First, try to understand question 1. You take 1 or 2 minutes and try to understand what we have done till now. Then we will proceed for the next question. Especially this question, you please try to understand what we have done here. It is very interesting and important question. The next question will be more important or interesting also. You people take 1 more minute and try to understand what we have done. Okay, so let us move to the next question, if it is clear. Find Fourier transform if t indicates Fourier transform of the following. Of directly we can write xt is equal to, there is a rectangular pulse, okay, minus a to plus a. Okay, this is a rectangular pulse and we have to find the Fourier transform of this. Okay, so if we write the value of xt, then we will get xt is equal to 1 for minus a less than t less than plus a. And for any other value it is 0. Okay, so we can, from the definition we can find x omega is minus infinity to plus infinity xt e to the power minus j omega t dt. Okay, so x omega is this. Fine. Now as xt is 1 for minus a to plus n, for any other value it is 0, right? So can we write it like this, minus a to plus a e to the power minus j omega t dt is equal to, it is simple integration, e to the power minus j omega t divided by minus j omega, and t's value is minus a to plus a. Till now it is fine. So we can write it minus 1 by j omega e to the power minus j omega a minus e to the power plus j omega a. Till now it is clear. First try to understand what I have done till now, then we will proceed. And here is a very interesting question. Okay, fine. If it is clear, then we will move forward. Can we write it like 2 by omega multiplied with e to the power j omega a minus e to the power minus j omega a divided by 2j. Please try to understand this step. 2j. Can we write it like this? Yes, we can write. We have simply rearranged it and multiplied with 2, divided by 2 and rearrange it. Right? So this is what is this? This is sine A omega. So this is 2 upon omega sine A omega. Right? So this is a sinc function. And sine A omega will be 0 for A omega is equal to n pi. So omega is equal to n pi by A. So note, what is note? That for a rectangular pulse, Fourier transform is a sinc function and its value is 0 for omega is equal to n pi by A. So we can draw it also, right? Okay. You people take 1-2 minutes and try to understand what we have done here. This whole steps. Then we'll move forward. Try 2 minutes. Take 2 minutes and try to understand what we have done till now. If there is any query, you can ask. Okay. So if there is no query, we will move forward. Now, one interesting question is, find Fourier transform. Fourier transform of xt is equal to delta t minus 1. Okay. Okay. So we will solve it in two different ways. Okay. First, x omega. Let us try to solve. This is like this. in similar way, right? So we can write it like minus infinity to plus infinity. Delta t minus 1 e to the power minus j omega t dt. Okay. Here also we are doing the same thing. Now the question is, what is the value of delta t minus 1? Delta t minus 1 is 1 for t is equal to 1 and 0 for any other value of t, right? So we will simply get e to the power minus j omega t at t is equal to 1. So we will get e to the power minus j omega. Fine. Now we will solve it in another way. We know the time shifting property. Time shifting property. Fine. What is time shifting property? If the Fourier transform of ft is x omega, then this was if, then xt minus t0 its Fourier transform will be e to the power minus j omega t0 into x omega. Fine. Now you people use time shifting property and try to solve the same question. You take 2 minutes and try to solve. If you get the answer, you match your answer with my answer. If you do not get, then I will solve it for you. Okay? Take 2 minutes. Take 1 more minute and try to solve, then I will solve it for you. Okay, then let us solve. We know that Fourier transform of delta t is is 1, right? We have solved it earlier. So Fourier transform of delta t minus 1 will be using the same property, time shifting property. So e to the power minus j omega 1, that means minus j omega multiplied with x omega, that means 1. So this is what we are getting. Okay, so take 1 or 2 minutes and try to understand what we have done in two similar way. One more minute you take and try to understand what we have done till now. Okay, so let us start. A very interesting question. Find Fourier transform of cos omega 0 t. It is very interesting question. For this you have to know two things. One is frequency shifting property. So let us try to understand frequency shifting property now. Frequency shifting property says if Fourier transform of xt is x omega, then e to the power j omega 0 t multiplied with xt its Fourier transform will be x omega minus omega 0. Fine. This is frequency shifting property. And one more thing you should know for solving this question, and Fourier transform of 1. You people try to solve this at your home. That Fourier transform of 1 will be 2 pi delta omega. You can solve this easily. You people try to solve at your home, not now. Okay. So now what we will do? We will shift the frequency. So if we write e to the power j omega 0 t its Fourier transform will be 2 pi delta omega minus omega 0 and Fourier transform of e to the power minus j omega 0 t its Fourier transform is 2 pi delta omega plus omega 0. Fine. Okay. So now if we sum these two, then we will get e to the power j omega 0 t plus e to the power minus j omega 0 t its Fourier transform will be 2 pi multiplied with delta omega minus omega 0 plus delta omega plus omega 0. Fine. We will divide it by 2. Then we will get e to the power j omega 0 t plus e to the power minus j omega 0 t divided by 2. Its Fourier transform is pi multiplied with delta omega minus omega 0 plus delta omega plus omega 0, and this is nothing but cos omega 0 t. So cos omega 0 t its Fourier transform is pi delta omega minus omega 0 plus delta omega plus omega 0. So this is our solution. This is the way we have solved. It may look difficult, but it is not that much. So try to understand what we have done till now. Okay, especially this portion. Then we will move towards the next question. Take 2 or 3 minutes and try to understand. Hope you understand. You take 1 more minute to understand. Okay. So now we will proceed. If there is no doubt, we will proceed. Find Fourier transform of sine omega 0 t. Okay. In similar manner, we will solve. First, let us try to understand again the fundamental. Look, here what we have done, Fourier transform of 1 is 2 pi into delta omega. So if we shift the frequency from omega to omega minus omega 0, then in time domain we will get e to the power j omega t 0. That means the Fourier transform of e to the power j omega 0 t is 2 pi delta omega minus omega 0. And e to the power, the Fourier transform of e to the power minus j omega 0 t is 2 pi into omega plus omega 0. And then we sum up, and whatever we have done here. Now we will not sum, we will subtract. So if we write e to the power j omega t 0, sorry, j omega 0 t minus e to the power minus j omega 0 t, so its Fourier transform will be two pi multiplied with delta omega minus omega 0 minus delta omega plus omega 0. Fine. Delta omega minus omega 0 minus delta omega plus omega 0. Now we will subtract it with 2j. So if we write it e to the power j omega 0 t minus e to the power j omega 0 t divided by 2j, its Fourier transform will be pi by j delta omega minus omega 0 minus delta omega plus omega 0. Okay, so this is nothing but the sine omega 0 t. So sine omega 0 t, its Fourier transform is pi by j delta omega minus omega 0 minus delta omega plus omega 0. So this is the answer. This is the Fourier transform of sine omega 0 t. Okay, you people take 2 or 3 minutes and try to digest what I have done till now. In between, if there is any query, you can ask. Take 1 more minute and try to understand what we have done till now. Then we will proceed further. Try to understand what we have done till now and then we will proceed further. Okay, take 1 more minute and try to understand what we have done. We have calculated the Fourier transform of cos omega 0 t and sin omega 0 t in this way, right? Using the properties of the Fourier transform. Okay, let's start next question. Question 7. Find Fourier transform of ut. Okay, for this, to solve this, we will use another property of Fourier transform, that is integration property. Let us see what is integration property. Integration property. What is integration property? If Fourier transform of xt is x omega, capital X omega, then integration of minus infinity to t x tau d tau. Its Fourier transform will be x omega upon j omega plus pi x0 delta omega. Okay, now we will solve. We know that delta t, Fourier transform of delta t is 1. So if we integrate it with minus infinity to t, delta tau d tau, its Fourier transform what will be? X omega is 1, so 1 by j omega plus pi into 1 into delta omega. That means pi multiplied with delta omega, and this is nothing but the ut. So ut, the Fourier transform of ut is one upon j omega plus pi delta omega. Fine. Please take 2-3 minutes and try to understand what we have done here. Then we'll proceed further. But let us try to solve another question and then you will take time. Okay, take your time first. Try to understand because next question is related to this question only. So take 2-3 minutes and try to understand what we have done here. Next question is very related to this. Take 2-3 minutes. How we have used integration property in solving the Fourier transform of ut. Ut is nothing but the step, right? Unit step. Take 2-3 minutes and try to understand what we have done till now. Take one more minute and try to understand what we have done. Okay, so let us try to solve the next question. Find Fourier transform of u minus t. Okay, so here we need to know the time reversal property. Time reversal property. if Fourier transform of xt is x omega, then Fourier transform of x of minus t is x of minus omega. Okay, so if we apply time reversal, then we will get u of minus t is equal to, we have this minus 1 upon j omega plus pi into delta of minus omega. Now delta of minus omega is nothing but delta omega. This is known to us, or we know. So u of minus t is nothing but minus 1 by j omega plus pi multiplied with delta omega. This is the solution. You people take 2 minutes and try to understand what we have done till now. Then we will proceed in a very interesting question where we will use time reversal property again. Please try to understand what we have done here. Now we will solve a very interesting question. Question number 9. Find Fourier transform Fourier transform of e to the power minus a mod t. Can anyone solve this? Please take 3-4 minutes max. Try to solve this question. Then I will solve. And if you can solve, you match your answer with my answer. If you cannot, I will solve it for you. But first you try. It is very interesting and important question. And next question will be related to this question only. Here time reversal property will be used. Try 2-3 minutes more and try to solve. Can we write e to the power minus a mod t is equal to e to the power minus at for t greater than 0 and e to the power plus at for t less than 0, right? Take 2-3 minutes and try to solve. Then I will solve it for you. Take 2 more minutes and try to solve. Can you solve it? You should at least try. Any of you should try. Okay. If you cannot, then I will solve it for you. We can write e to the power minus a mod t is equal to e to the power a minus at for t greater than 0 and e to the power at for t less than 0, right? So it is nothing but we can write it like e to the power minus at ut plus e to the power at u of minus t. Okay. Now do we know the Fourier transform of e to the power minus at ut? Yes, it was the very first question. Look at this. E to the power minus at ut was 1 upon a plus j omega, right? So let us write e to the power minus at ut, its Fourier transform will be 1 upon a plus j omega. Okay, so applying time reversal property, we can write so e to the power 8t u of minus t will be, this is plus, right? Fourier transform of this is 1 upon a minus j omega. Now if we sum this, so if we sum up these two, e to the power minus a mod t, its Fourier transform will be 1 upon a plus j omega plus 1 upon a minus j omega is equal to a square minus j omega whole square. That means a square plus omega square, and it will be a minus j omega plus a plus j omega is is, is equal to 2a divided by a square plus omega square. Fine. So what we have done, please take a glance at this. What we have done, please try to understand. Take 2 minutes to take your time to understand what we have done, especially this part. If there is any question, any query, please ask. Then we'll move to the next question. Please try to understand what we have done in this question. Then we will move to the next question. So many questions are left to cover, but you have to understand each and every question, right? It doesn't sense that we will solve more and more question and you understand nothing. So all the effort will give no results, right? So I'm giving you time to understand each and every question. What we have done here, we have divided e to the power minus a mod t into two parts. One is for t greater than 0, one is for t less than 0. For t greater than 0, it is e to the power minus at, and for t less than 0, it is e to the power at. It is clear? Is it clear? Okay. If it is clear, then we can write e to the power minus at ut plus e to the power at u of minus t. So this is nothing but this. Fine. Now what we know, that is, we know the Fourier transform of e to the power at ut. And using the time reversal property, we can know the Fourier transform of e to the power at u of minus t. So we have calculated this, and now we sum up. That means e to the power minus at ut plus e to the power at u of minus t is equal to 1 upon a plus j omega plus 1 upon a minus j omega. And e to the power minus at ut plus e to the power at u of minus t is nothing but e to the power minus a of t, a of mod t, sorry. And if we calculate 1 upon a plus j omega plus 1 upon a minus j omega, we will get a minus j omega plus a plus j omega upon a square plus omega square is equal to 2a by a square plus omega square. Simple. Okay. Now we will move to the question 10. Or if you want, you can take 2 more minutes to understand. Each and every question understanding is important. Okay. So let's question 10. Okay, let us create some space. Okay, question 10. Find Fourier transform of 1 upon a square plus t square. Can you solve this? This is square rather. Can you at least try to solve this? If I give you 1 minute or 2 minutes, can you try to solve this question? Find Fourier transform of 1 upon a square plus t square. Please solve and tell me the answer. Okay, you take 2-3 minutes. Then I will solve it for you. Take 2-3 minutes and try to solve first. Then I will solve it for you. Take 2 minutes more and try to solve. Please take 2 more minutes and try to solve and then tell me the answer. Then I will solve it for you. 1 more minute. To solve this question, we will apply duality property. Duality property. Okay. What duality property says, if Fourier transform of xt is such, it will be capital T, right? Fourier transform of ft is x of omega. Then Fourier transform of x of t. Its Fourier transform will be 2 pi x of small x of minus omega. Okay, if Fourier transform of small xt is capital X omega, then Fourier transform of capital Xt is 2 pi into small x of minus omega. This is called duality property of Fourier transform. Now, from the previous question, we know that 2a, what we know? That e to the power capital mod t, e to the power a of mod t, its Fourier transform is two a square plus omega square. Okay, so if we apply duality property, then we will get 2a divided by a square plus t square Fourier transform of this will be 2 pi e to the power minus a of minus mod omega, which is nothing but omega, right? So if we cancel out 2, then we will get a upon a square plus t square. Its Fourier transform will be pi e to the power minus a mod omega. Okay, so if we divide it by a, then 1 upon a square plus t square, its Fourier transform will be pi upon a e to the power minus a mod omega. So this is the answer. Please take 2 minutes and try to understand what we have done. Then we will go for the next question. A very interesting question. Take 2 minutes and try to digest what we have done. Take 1 more minute and try to understand what we have done till now. Then we will go for the next question. Okay, let us move to the next question. Question number 11. Find Fourier transform Fourier transform of t e to the power minus 80 ut. E to the power minus 80 ut is full form Fourier transform, we know. But how we can find Fourier transform of t e to the power 80 ut? Very interesting question. Right. So here we will use another property, that is differentiation in frequency domain. We have another property, that is differentiation in frequency domain. If it says if Fourier transform of xt is x omega, then minus j t xt, its Fourier transform will be differentiation in frequency domain. Is d omega omega multiplied with x omega. Fine. Now we know that e to the power minus 80 ut. Its Fourier transform is 1 upon a plus j omega. How we are getting this? It was our first problem, right? Let us go to this. This is first problem. Xt is equal to e to the power minus at ut. Its Fourier transform is this way we have solved from the definition of Fourier transform. Please look into it for 1 minute and you will understand. No need to explain this again. For those who have joined after that, for those I am showing it once again. X omega is minus infinity to plus infinity e to the power minus at ut into e to the power minus j omega t dt. Fine. Okay. And it will be minus infinity to infinity my e to the power minus of a plus j omega t ut dt. Because it is ut is the step input step function, unit steps basically. So its value is 1 for t greater than 0 and 0 for t less than 0. So it will be 0 to infinity e to the power minus a plus j omega t dt. And now it is simple integration. We will get e to the power minus a plus j omega t minus a plus j omega 0 to infinity. And it is minus 1 upon a plus j omega 0 minus 1, and finally we are getting this, right? So we are using this principle, this formula here. Okay. So now if we write minus j into t multiplied with xt, that means e to the power minus at ut. Its Fourier transform is simple. It is d dt of 1 plus a plus j omega. Fine. So let us calculate what a plus j omega is. Sorry, d omega, not d dt. Can we write it? d omega of a plus j omega minus 1. We can write, right? So we will get minus 1 into a plus j omega minus 2 into j. That means minus j upon a plus j omega square. Fine. So we are getting minus j t e to the power minus 80 ut. Its Fourier transform is minus j a plus j omega square. So if we cancel out minus j, then we will get t e to the power minus 80 ut. Its Fourier transform is 1 upon a plus j omega square. Fine. So this is the solution. You take 2-3 minutes to understand it, what we have done here, and how we have done. That is important. Then we will go for the next question. You take 1 or 2 minutes more to understand what we have done till now. Then we will go for the next question. We will go for the question number 12. Take 1 or 2 minutes more to understand what we have done till now. Then we will go for the next question. And next question is very interesting. Take your time and try to understand. Understanding is important rather than solving so many questions. If we solve 20 questions and you understand nothing, then there is no result, right? And if we solve 10 questions and you understand all the 10 questions and the methods how we are solving this, then you can solve 100 questions, right? And more. Take 1 more minute and try to understand. Then we will go for the next question. Okay, let us move to the next question. Question number 12. Probably this is the last question of today's session. Let us solve quickly. Okay, otherwise we will not get enough time. Find Fourier transform of e to the power 3t u of minus t plus 2. We know that e to the power minus at ut. Again the same thing, its Fourier transform is 1 plus 1 divided by a plus j omega. Okay, how we are getting? We have solved that in the first question here. Okay, okay, so we can write e to the power minus 3t ut is its Fourier transform ft. 1 upon 3 plus j omega. Okay, so if we write e to the power minus 3 t plus 2, our goal is to find this, right? U of t plus 2. Then its Fourier transform will be e to the power j 2 omega 1 upon time shifting property, right? 3 plus j omega. Okay, now can we write it e to the power minus 3t u of t plus 2 its Fourier transform is here we will get e to the power minus 60, so it will come here. Here we will get e to the power 6 plus j 2 omega multiplied j omega. Can we write it? Yes, we can write, right? So what we have written here, we will get e to the power minus 3t multiplied with e to the power minus 6 and e to the power minus 6 if we multiply both sides with e to the power plus 6, then we will get this, right? Okay, now we will apply time reversal property. So applying time reversal property, we will get e to the power 3t u of minus t plus 2. Its Fourier transform is e to the power 6 minus j2 omega multiplied with 1 plus 1 upon 3 minus j omega. Fine, so this is our ultimately solution. Okay, so I will share it with you. Let us stop today here.